Welcome. In this session on natural deduction, we'll begin our exploration of the semantics of predicate logic. This will occur in a meta-logic, and when we need to, we'll suppose that we're working in some variation of Zermelo-Fraenkel set theory. That is, we'll be looking at this from a set theory point of view. Let's recall propositions. When we were looking at propositions, we would write, for example, a truth table. We might have two variables and we might have some formula that involves those variables. And the way we did that was we wrote down all of the possible values that each of these variables or propositions could take on. And then we might, for example, have a formula and we would write down the truth table. Now let's observe that each row is a model. And when we said that we had a model for a formula, what that meant was that we had an assignment of truth values to every proposition in the formula. What do we have in predicate logic? Well, we have something much more complicated, right? So now we must account for, well, the immediate thing that we have to account for is predicates. And that is going to be a session of its own. We also have to account for functions. And we didn't use functions much in the proofs. In semantics, we'll care about functions because semantics are where we start to explore how we can apply this predicate logic to analysis of computer programs. And functions are a key part of computer programs. We'll also have to have what is called a universe of discourse. And a universe of discourse is all of the objects that we're going to allow in a model. So some authors use the set D for discourse, and Huth and Ryan use the set A. So we'll use the script set A to be our universe of discourse. For example, we might want to restrict our universe of discourse to be the natural numbers. So it would be 0, 1, 2, 3, etc. We might only want to talk about binary, 0 and 1. We might want to be talking about logic with 4 values. So it might be 0, 1, 2, 3. And so that would be a base 4 logic. So we'll have to account for all of these. And the way that we'll do this is we'll start having, we'll call these, so we'll have to have these. And so we need predicates, functions, universe of discourse, and the other thing we'll have to have is unbound or free variables. And these together are what we'll call a model. We'll have some notation. And the notation is in a formula, or we'll call it in syntax, and then in our semantics, which is in a model. And we'll draw a distinction here. When we have a function, we'll write that as f. And in semantics, we'll write it as f, and we'll put a script m as a superscript to indicate that this this is a function that we're going to work with syntactically. That is, we're going to use rules of natural deduction. And this is, we are talking about a specific function. For a predicate, we'll write this syntactically as P. And so when we're doing our proofs, we'll write this as P, Q, R, etc. In the semantics, we'll write this as P, and then we'll superscript it with an M so that it's clear that we're now talking about one specific predicate and what that predicate does within that semantic model. We'll have our discourse, and this won't be any one of this will not be syntactic. This is a purely semantic notion, and that will be A. And we'll get to the matter of unbound variables much later in a subsequent session. So together, all of these are a model, and we'll write a model using a script M. What we'll need to describe for a model is we'll need to specify a universe of discourse, we'll need to define every function, and we'll need to define every predicate. To make these definitions simpler, we'll talk about the set of functions. And this is a semantic notion, and for this, we'll write this as script F. We won't use it very often, but when we do, we'll write it as a script F, and we'll also have a set of predicates. And that will be a script P. Again, these are terms that we'll have to define when we specify a model. It'll usually be very small. For example, we may have no functions at all in a model, and there may be only 2 predicates. So as we begin to elaborate these, we'll start to use these more. So this is the problem that we have, is when we go from propositional logic to predicate logic, the idea of a model expands from being just one row of a truth table, and now we have to say, what are we talking about and what do we mean?